We are group 7 for MXET300 final project, and the project design that we attempted was the Feral tank. I am Scott Rowland.
I'm Angela Duron.
My name is David Tork.
Audio.
For this mission statement, essentially what we're planning to do is make a tank that finds targets that are colored in a certain way and deliver them gifts for the holiday season. This gift package was a little marshmallow, which we used to spread holiday cheer. This entailed using camera vision to identify the correct targets based off color. That we chose was green. We did a program correlation between three different modules that were based off mechanical advantage, such as a pulley system and a servo to actuate a separate power system. And we implemented safety factors such as the servo so that we don't overexert the voltage on the main system. We also implemented object avoidance systems so that it doesn't run into any objects, or the parts that are hanging off the robot do not get damaged in the process of movement, so the range is outside of the robot's width. The timeline, we stuck to the timeline. It went fairly well, so we were able to get everything done and ready and fully assembled, and had testing right in time for final implementation and project completion.
So the final results essentially entailed a successful object detection and avoidance. So essentially the scuttle was fully capable to roam around multiple different environments and essentially avoid each object or obstacle that was placed in front of it, including as well as identifying the color green in this case. And once that green color was selected, then of course the result was a functional firing mechanism. So the actual mechanism shot out treats to the nice children, and that was the successful operation that we were capable of doing. And yes, it was able to go in multiple different environments and operate accordingly. The modifications we made to our original design essentially was some mechanical issues. There was the intention of having just a standard ammunition and just a barrel and a pneumatic system, but the pneumatic system was pulled. We included a fully operational DC motor fan that we rigged from a old leaf blower. And that was implemented to essentially have a loading clip designed into it. So as soon as the clip was then loaded and then slowly moved on by a step motor when the green target acquisition was acquired, then the switch would be pressed to release an amount of airflow to go ahead and have that projectile shoot and deliver those nice treats. So in regard with that, so for the loading system itself with the mag, a pulley system was designed with it. Initially, it was supposed to have a gear train, and before that, it just essentially entailed a rubber band mechanism, but ultimately modifying a step motor and plugging that in to have communication with the Raspberry Pi and sending a signal, and especially utilizing some Arduino. We were able to operate the step motor to pull this clip along with a piece of string in increments that were needed to perfectly get those alignments, as well as the modification to HSV filters. So we initially wanted to do color differentiation, but the red hues weren't picking up as well in regard to adding multiple. So we just solely stick to the green, and again, just changing the pneumatic to airflow.
And here is our demo. So we have 2 separate courses and then 1 additional function by the robot, just demonstrating its capabilities a little bit more. So for our first test course, we have a narrow corridor, which was essentially built off of a kitchen in one of our apartments with an island that the robot had to navigate around, as well as a couple additional obstacles. And so you see the LiDAR picking up on the objects in front of it and near it, and just trying to figure its way around the course. It gets caught up a little bit, mostly due to the range of the LiDAR, but as we can see, it still accomplishes its goal of obstacle avoidance using the LiDAR sensing, and is able to avoid running into many obstacles aside from its blind spot, which is, of course, directly behind the LiDAR. And here we start to give it more obstacles using our own bodies to just kind of speed up the process and help it find its way out a little bit quicker. And finally, after getting unstuck, it does sense the target, and it misses the first shot, and as a result, it still sees the green target and it readjusts and fires again, thus successfully knocking down the target and completing the first obstacle course. For the second course, we had a larger space with multiple obstacles, but more distance between those obstacles, and this course had 2 targets as opposed to 1. And we release it from the base, thus sending it on its way. Naturally, with less obstacles, it makes it easier for the robot to get unstuck more quickly, but when there are things on multiple sides of it, it struggles a little bit more, but still ultimately navigates its way out. Here we added a dynamic obstacle. And as you can see, the robot picks it up well and readjusts course. And then it sets its sights on the first target, knocks it down successfully. And then once the target is removed, having been hit, it proceeds to look for another obstacle or object. And here, even though it misses the first shot, we do see that it picked up on the green and responded accordingly with the firing mechanism. And then just from additional trials with our first test course, you can see it detect the green object here. And since it's still detecting the green object, it again tries to readjust and successfully knocks down the target. And then for our work distribution, I, Scott Rowland, focus mostly on the code as well as implementing the Arduino with the stepper motor. Just for ease of code, our stepper motor functions were really finicky in Python, but that was mostly because the stepper motor it did come with the Arduino, so it was part of that kit, and that's what the stepper motor driver worked for as well. But I focused on the Arduino integration with the Raspberry Pi, as well as the stepper and servo motor actuation. The servo motor was directly tied to the GPIO of the Raspberry Pi, and then I focused on the main coding files, making the camera vision and LiDAR work together in unison for the motion of the robot. as well as the implementation of the firing mechanism after the green colored objects were detected. Angela Duron focused primarily on integrating all of our separate components, so making all of the sensors work with all of the hardware, making the firing mechanism trip when the servo motor was pressed, making sure our switches were working. She also assisted with the HSV filter testing and enabling, and was able to discover that the red color wasn't working well, primarily because of the range of the red color on the color spectrum, since it went up all the way to the max, as well as started at the very minimum values. That's why it was giving us trouble. And then lastly, focused on making sure that the loading mechanism worked properly, with the stepper motor pulling the magazine out more, thus loading another round whenever we needed to load another shot. And that entailed a lot of specifying exactly how much the stepper motor was to turn, setting up the pulley system so that the range was proper, the arms of the pulley were properly configured to make sure that each pull of the stepper motor loaded a new shot. And then David Tork did the heavy lifting in terms of assembling our shooter. He did all the 3D printing himself, much of the design and testing using SolidWorks, and he was able to ensure that our fan was functioning properly by setting up a power supply and ensuring that we had the proper connections to it to get it working in the first place, as well as housing that fan and motor inside the 3D printed designs that he made. And that's where the assembly portion comes in. And he also created all the other 3D printed components for mounting everything to the frame of the scuttle and ensuring that nothing was too wobbly and that the recoil of the firing mechanism did not interfere with any of the rest of the scuttle's operation. And that is it for our final presentation. Thank you so much.